When a simple woman walked into that classroom and solved the impossible math problem in just 47 seconds, their reaction was pure shock. What happened next would challenge everything they believed about genius, education, and the hidden brilliance that walks among us every single day. Elena Vasquez adjusted her reading glasses as she wheeled the book cart down the marble hallway of Cambridge University's mathematics department. At 38, she'd been working as a library assistant for 7 years, and these evening rounds had become as familiar as breathing. The fluorescent lights hummed overhead, casting long shadows across the prestigious halls where some of the world's brightest minds gathered daily. Elena had always found comfort in the quiet solitude of her job, organizing, cataloging, ensuring every book found its rightful place. But tonight felt different. As she passed room 301, the advanced mathematics classroom, something caught her eye. The door stood slightly ajar, and through the gap, she could see the massive blackboard covered in complex equations. White chalk marks sprawled across the dark surface like a mathematical constellation. Elena paused, her curiosity piqued. She'd walked past this room countless times, but tonight, the equations seemed to call out to her. Years of working in the mathematics section had exposed her to countless theories, formulas, and proofs. She'd developed an unusual habit of reading mathematical texts during her lunch breaks, not for any practical purpose, but simply because the logic fascinated her. Her grandmother used to say that numbers spoke their own language, and Elena had always believed she could hear their whispers. She glanced down the empty hallway, then quietly pushed the door open wider. The classroom was dimly lit by the emergency lighting, but the blackboard was clearly visible. At the top, written in Dr. Whitmore's distinctive handwriting, were the words, "The Riemann Hypothesis, Millennium Prize Problem." Elena's breath caught. She'd read about this, one of the most famous unsolved problems in mathematics, worth $1 million to whoever could prove it. But what she saw on the board wasn't just the basic hypothesis. It was an intricate web of attempted proofs, crossed-out equations, and frustrated erasures. The board told a story of brilliant minds hitting an intellectual wall. She stepped closer, her eyes scanning the work. From what she could see, multiple attempts had been made, different approaches, various mathematical techniques, all leading to dead ends. Red chalk marked the areas where errors had been identified, while blue chalk showed alternative paths that had also failed. This wasn't just homework. This was the collective frustration of some of the most gifted mathematicians in the country. Elena found herself studying the patterns, following the logical progression of each attempt. Her mind began to trace the mathematical reasoning, identifying where each approach had faltered. It was like reading a detective story, where every clue led to another mystery. She'd always had this strange ability to see mathematical relationships in ways others couldn't. When she was cataloging books, she'd organize them not just alphabetically, but in patterns that somehow made intuitive sense. Her supervisors had noticed her uncanny ability to locate misplaced materials, attributing it to diligence rather than the mathematical thinking that actually guided her methods. But standing here, looking at this impossible problem, Elena felt something stirring within her. It wasn't arrogance or overconfidence. It was recognition, like seeing a puzzle piece that might fit in a way others hadn't considered. She checked her watch. 8:47 p.m. The building would be nearly empty except for security guards making their hourly rounds. Her supervisor had given her the master keys months ago, trusting her to lock up the library sections when her shift ended. Those same keys would open this classroom. Elena's heart raced as she considered what she was thinking. A library assistant, daughter of immigrants, high school graduate who'd taught herself advanced mathematics through borrowed textbooks. Was she really considering tackling a problem that had stumped PhD mathematicians for months? The rational part of her mind screamed that this was foolish, but another part, the part that had always seen patterns where others saw chaos, whispered that maybe, just maybe, sometimes fresh eyes could see what experienced ones had missed. Dr. Theodore Whitmore had been staring at this same blackboard for 8 months, and it was slowly driving him insane. The 62-year-old mathematician had dedicated his entire career to number theory, publishing papers that had advanced the field significantly. He'd solved problems that others deemed impossible, earned tenure at one of the world's most prestigious universities, and commanded respect from colleagues worldwide. But this particular problem had become his white whale. "Professor, maybe we should approach it from a different angle," suggested Marcus Chen, one of his most promising doctoral students. The young man stood beside 3 other graduate students, all brilliant minds who'd been working on this proof for months. "We've tried every angle, Marcus," Dr. Whitmore replied, his voice heavy with frustration. He set down his chalk and turned to face his students. Galois theory, complex analysis, algebraic geometry. We've thrown everything at this problem. The Riemann hypothesis had been taunting mathematicians for over 160 years. Simply put, it dealt with the distribution of prime numbers and the zeros of the Riemann zeta function. But the implications of proving it would revolutionize mathematics, cryptography, and our understanding of numbers themselves. Sarah Rodriguez, another doctoral candidate, pushed her glasses up her nose. "What if we're overcomplicating it? Sometimes the most elegant solutions are surprisingly simple." Dr. Whitmore almost smiled. "Sarah, this isn't a homework assignment. The greatest mathematical minds of the past century and a half have attempted this proof. Hilbert called it one of the most important problems in mathematics. It's one of the Millennium Prize problems for a reason." The weight of that statement settled over the room. The Millennium Prize problems were 7 of the most difficult and important unsolved problems in mathematics. Each carried a $1 million reward from the Clay Mathematics Institute. Only one had ever been solved. "Look at this board," Dr. Whitmore continued, gesturing toward the chaotic sprawl of equations. "Every line represents hours of work, multiple approaches, countless calculations. We've consulted with colleagues at Harvard, MIT, Princeton. We've used computer modeling, explored connections to quantum physics, even examined the problem through the lens of fractal geometry." Jessica Park, the youngest of the group, raised her hand tentatively. "Professor, what if someone with a completely different background looked at it? Someone without our preconceptions?" Dr. Whitmore's expression darkened slightly. "Jessica, mathematics isn't art therapy. You can't solve century-old problems through fresh perspective alone. This requires deep understanding of complex mathematical concepts that take years to master." The students exchanged glances. They had all heard variations of this speech before. Dr. Whitmore was brilliant, but he was also intensely traditional and H-y. Elena waited until the hallway fell completely silent before using her master key to enter room 301. Her hands trembled slightly as she turned the lock, not from fear of being caught, but from the excitement of standing face to face with mathematical history. The classroom felt different in the quiet darkness. She flipped on the lights and approached the blackboard, her eyes immediately drawn to the complex web of equations covering its surface. But to understand why Elena dared to attempt what brilliant PhDs couldn't solve, you'd need to know her story. Growing up in a small apartment in East Boston, Elena had been surrounded by limitations, but not by ignorance. Her father, Miguel, worked construction, and her mother, Carmen, cleaned office buildings downtown. Neither had formal education beyond elementary school, but they possessed something more valuable: an unwavering belief in the power of learning. "Mija," her father used to say, watching 8-year-old Elena arrange her crayons in the complex mathematical patterns, "your mind works differently. Don't let anyone tell you that's a problem." Elena's mathematical awakening had come through necessity. When she was 12, her father was injured on a construction site, and the family struggled to understand the insurance paperwork, medical bills, and legal documents that buried them. Elena became their translator, not just of language, but of logic. She discovered that complex problems could often be broken down into smaller, manageable pieces. Insurance calculations became algebra. Medical billing patterns revealed statistical relationships. Legal language followed logical structures that, once understood, became predictable. High school had been a blur of part-time jobs and family responsibilities. But Elena had found refuge in the public library. While her classmates studied for tests, she devoured mathematics textbooks that were decades ahead of her grade level. She taught herself calculus from a torn book she'd found in a dumpster behind the library. Her senior year math teacher, Mrs. Patterson, had noticed Elena's unusual ability to solve problems using methods that weren't in any textbook. "Where did you learn this approach?" she'd asked, after Elena solved a complex geometry problem using a technique that seemed to come from nowhere. "I just see it differently," Elena had answered, unable to explain how her mind naturally found patterns and connections that others missed. Mrs. Patterson had encouraged Elena to apply for scholarships, to pursue mathematics in college. But when Miguel's injury worsened and Carmen developed complications from diabetes, Elena's academic dreams took a backseat to survival. She'd found work at the university library through a community outreach program. The job was supposed to be temporary, just until her family stabilized financially. That was 7 years ago. But those 7 years hadn't been wasted. Working in the mathematics section had given Elena access to resources she'd never dreamed of. During lunch breaks and quiet moments, she'd continued her self-education. She'd read Euler, studied Gauss, worked through Riemann's original papers. More importantly, she'd developed her own mathematical intuition. Unlike formally trained mathematicians who learn to approach problems through established methodologies, Elena's mind worked in patterns and connections. She saw mathematics as a living language rather than a rigid system of rules. Standing now before the blackboard, Elena felt that familiar stirring, the same feeling she'd had when solving her family's insurance problems, when finding patterns in library catalogs, when organizing complex information in ways that somehow just made sense. She studied the failed attempts covering the board. Each approach was technically sound, methodologically correct, and completely conventional. The mathematicians had followed established paths, used proven techniques, applied time-tested strategies. But what if the solution lay not in following the established path, but in creating an entirely new one? Elena picked up a piece of chalk, her heart pounding. She wasn't thinking about degrees or credentials or the opinions of people who might discover her work. She was thinking about numbers, patterns, and the whispered language of mathematics that had been calling to her since childhood. What happened next would change everything. Elena stood before the blackboard at 9:23 p.m., chalk in hand, staring at mathematical equations that had frustrated some of the world's brightest minds. But she wasn't intimidated. She was curious. The first thing Elena did was something that would have horrified Dr. Whitmore. She erased a section of the board, not the original hypothesis, but the complex web of failed attempts that surrounded it. She needed space to think, to see the problem clearly without the visual noise of previous failures. As she cleaned the slate, Elena's mind began to work in the way that had always set her apart. She didn't think about the Riemann hypothesis as a mathematical monument to be conquered. Instead, she thought about it as a question that simply needed answering. The hypothesis, in its essence, dealt with the distribution of prime numbers, those numbers divisible only by one and themselves. Where do they appear? Is there a pattern? Can we predict their location along the number line? Elena had always seen prime numbers differently than most people. While others saw them as random, scattered points, she saw them as notes in a musical composition, seemingly chaotic individually, but part of a larger, beautiful harmony when viewed from the right perspective. She began writing, but not with the formal mathematical notation that covered the rest of the board. Instead, she started with simple observations, building her understanding step by step, like constructing a bridge across a river. First, she wrote down the pattern she'd noticed years ago while cataloging numbered mathematical texts. Prime numbers, when mapped in certain ways, created visual patterns that reminded her of the architectural drawings her father had shown her from his construction work. There was an underlying structure, a foundation that supported everything above it. Elena's approach was unconventional because it was visual and intuitive rather than purely analytical. She began drawing diagrams that connected the mathematical concepts to spatial relationships. Where formal mathematicians saw abstract numbers, Elena saw geometric patterns. As she worked, something remarkable began to happen. The solution didn't emerge through complex calculations or sophisticated theorems. Instead, it evolved organically, each step building naturally on the previous one. She found herself using mathematical techniques she'd learned from different sources. A bit of number theory from a textbook she'd read 3 years ago, combined with geometric insights from her father's construction experience, merged with logical structures she'd developed through years of organizing complex information systems. The breakthrough came at 10:17 p.m. Elena was exploring a connection between the zeros of the Riemann zeta function and a geometric pattern she'd noticed in the distribution of prime numbers. It was an approach so fundamentally different from conventional methods that no formally trained mathematician would have. Dr. Theodore Whitmore arrived at room 301 the next morning with his usual cup of coffee and sense of mathematical dread. 8 months of failure had worn him down, but he couldn't abandon the problem that had become his obsession. He unlocked the classroom door, flipped on the lights, and froze. The blackboard had been altered. Where yesterday there had been a chaotic mess of failed attempts, today there was something else entirely. The right side of the board, which had been covered in crossed-out equations and frustrated erasures, now displayed a clean, elegant mathematical proof. Dr. Whitmore's coffee cup slipped from his fingers, shattering on the floor. He approached the board slowly, his eyes scanning the unfamiliar work. The handwriting wasn't his, nor did it belong to any of his students. But more shocking than the unknown authorship was the content itself. This was a proof of the Riemann hypothesis, a complete, elegant, seemingly correct proof of the Riemann hypothesis. "Impossible," he whispered, but even as the word left his lips, his trained mathematical eye was following the logical progression of the proof. Each step built naturally on the previous one. The reasoning was sound. The techniques were unconventional but valid. Marcus Chen arrived 15 minutes later to find his professor standing motionless before the blackboard, his face pale with shock. "Professor, is everything all right?" Dr. Whitmore turned slowly. "Marcus, tell me what you see on that board." Marcus looked at the blackboard, and his expression immediately mirrored his professor's shock. That's a proof of the Riemann hypothesis." "Yes, but who wrote it?" "That's what we need to find out." Within an hour, word had spread through the mathematics department like wildfire. Faculty members, graduate students, and even the department head crowded into room 301, all staring at the impossible proof that had appeared overnight. Dr. Elizabeth Harper, the department head, was the first to voice what everyone was thinking. "Theodore, did one of your team solve it and not tell you?" "No," Dr. Whitmore replied firmly. "I know their handwriting, their mathematical style. This isn't from any of my students." Sarah Rodriguez was studying the proof more carefully than the others. "Professor, look at this approach. It's completely different from anything we've tried. Whoever wrote this is using geometric insights I've never seen applied to number theory." "The technique is sound," added Marcus, "but it's so unconventional. It's like someone approached the problem from an entirely different mathematical universe." Dr. Harper frowned. "Who else has access to this room?" "The cleaning staff, security guards, other faculty members with master keys," Dr. Whitmore listed. "But Elizabeth, you're missing the point. This isn't just someone with access. This is someone with deep mathematical understanding. This proof requires years of advanced study to even comprehend, let alone create." The department spent the morning verifying the proof, subjecting it to rigorous scrutiny. Computer calculations confirmed the mathematical reasoning. Independent verification supported each logical step. By noon, there was no denying the truth. The Riemann hypothesis had been solved. But by whom? Dr. Harper made the call to security. "I need to see all footage from this hallway between 8 p.m. and midnight yesterday." The security office was small and cramped, but the monitors were clear. The timestamp showed 9:15 p.m. when a figure appeared in the hallway, pushing a book cart. "That's Elena," said Jim Patterson, the head of security. "Elena Vasquez. She works in the library. Been here about 7 years." On the screen, they watched Elena pause outside room 301, look around the empty hallway, then use a key to enter the classroom. Dr. Whitmore felt the world shift around him. How long was she in there? Jim fast-forwarded the footage. She came out at 11:22 p.m., about 2 hours. 2 hours. A library assistant had solved in 2 hours what his team of PhD mathematicians couldn't solve in 8 months. The reaction was pure shock. Elena was cataloging returns in the library's mathematics section when Dr. Whitmore found her the next afternoon. She looked up from her computer screen to see the renowned professor approaching her desk, flanked by several graduate students and the department head. Her heart started racing. She'd known this moment would come, but that didn't make it any less terrifying. "Miss Vasquez," Dr. Whitmore began, his voice carefully controlled, "I believe we need to talk." Elena saved her work and looked up at the group of academics surrounding her desk. Their expressions ranged from curiosity to skepticism to barely contained excitement. "About what, Professor?" Dr. Whitmore studied her face, searching for any sign of deception or pretense. He found none. "About the Riemann hypothesis." Elena felt her cheeks flush. There was no point in denying it now. "What would you like to know?" The simple honesty of her response seemed to catch Dr. Whitmore off guard. He'd expected denial or explanation or some kind of defensive reaction. Instead, he was facing a calm, professional woman who seemed entirely unruffled by the academic storm she'd created. "How?" Dr. Harper interjected. "How did you solve a problem that has stumped mathematicians for over 160 years? Elena considered the question carefully. "I saw it differently, I suppose. You were all approaching it as a mathematical monument to be conquered. I approached it as a question that needed answering." "That's not an answer," Marcus said, his voice carrying a hint of frustration. "The mathematical techniques you used, where did you learn them?" "Books," Elena replied simply. "I've been reading mathematical texts during my breaks for 7 years. I work in this section, so I have access to everything." Sarah Rodriguez leaned forward. "But Elena, may I call you Elena? Reading about mathematics and actually doing advanced mathematical work are completely different things. The proof you created requires not just knowledge, but mathematical intuition that typically takes years of formal training to develop." Elena nodded. "You're right. But I think I've been doing advanced mathematical work without realizing it. Every day, I organize complex information systems, identify patterns in large data sets, solve logical problems. It's just that nobody ever called it mathematics before." Dr. Whitmore had been silent throughout this exchange, but now he spoke. "Elena, do you understand what you've accomplished? This proof could earn you $1 million from the Clay Mathematics Institute. More importantly, it places you among the ranks of history's greatest mathematicians." "I understand the significance," Elena replied quietly, "but I didn't solve it for recognition or money. I solved it because it was an interesting problem, and I thought I might have a unique perspective." The humility of her response was almost more shocking than the proof itself. Dr. Harper cleared her throat. "Elena, what are your educatio? This incredible story reminds us that genius can be found anywhere, in the person checking you out at the grocery store, in the night janitor walking past your office, in the quiet librarian who's been watching and learning all along. What amazing talents are hidden in the people around you? Share this story, and let me know in the comments where you're watching from. I love hearing from viewers worldwide. And if this story inspired you, please subscribe for more incredible tales of ordinary people doing extraordinary things. Because sometimes, the most brilliant solutions come from the most unexpected places.